All right, today we're going to be starting chapter 6, which is on solving equations. So, to solve equations, we have to know some properties of equations in order to do that. It says here the subtraction property of equality, and this is on page 438. The subtraction property of equality states that two sides of an equation remain equal when you subtract the same number from each side. So you need to think of an equation and the equal sign like the tip of a scale, where we want to keep things on one side of the equation equal to things on the other side of the equation. We want them to be weighted equally. And I didn't draw that very well. I should have drawn it like that. So that there's something teetering. There we go. That's what I really wanted. I wanted to draw like a scale. So whatever we do to one side of the equation, we must do to the other side of the equation. The subtraction property of equality says you can subtract the same thing from both sides, and it will keep it equal. So if we take a look at examples 1 and 2, example 1 says example 1 says x plus 6 equals 4. Well, we want to get x by itself. It's called isolating the variable. We want x to be the only thing on this side of the equal sign. We want it to be alone. So if you think of the equal sign as kind of like the wall, we want to move everything that's on the left side of the wall away from the variable. So we've got to get rid of this positive 6. The way we do that is by putting its opposite, which is a negative 6. Well, whatever we do to one side, we must do to the other side so that we can keep the scales balanced, so we can keep the both sides equal. So we're also going to put a negative 6 underneath the positive 4. Well, since positive 6 and negative 6 are opposites, they cancel each other out. They equal 0. So we can just drop down the x. We also drop down our equal sign, and then we take 4 and negative 6. Well, since those signs are different, using our integer rules, we would subtract and take the sign of the bigger looking number. The bigger looking number is the 6, so we know our answer will be negative, and when we subtract them, we get a 2. So our solution is x equals negative 2. Take a look at example number 2. The problem says negative 5 equals b plus 8. Well, first of all, notice where our equal sign is, our wall. B is not on the left-hand side of that wall. It's on the right-hand side of the wall. It doesn't matter which side the variable's on. Our goal is to get the variable on whatever side it is all by itself. So what needs to be moved is this positive 8. The way to get rid of adding 8 is to subtract 8. So we will put a negative 8 under the positive 8. But whatever we do to the right-hand side, we must also do to the left-hand side. So I'm also going to put a negative 8 under negative 5. We're going to drop our equal sign down. Positive 8 and negative 8 cancel each other out because they're opposites. So that's going to equal 0. So we can just bring down the letter B all by itself. Now we need to take negative 5 and negative 8. Following our integer rules, we know same signs mean to add and keep the sign. So we're going to have a negative answer, and we're going to add 5 and 8 together, and that's going to give us negative 13. So the solution to our equation is negative 13 equals b. If you like, you can rewrite it as b equals negative 13, if that makes you feel better about it. That brings us to the first set of letter problems, but we're going to go ahead and move on to the other examples. Let's take a look at this word problem. It says an angelfish can grow to be 12 inches long. So angelfish can be 12 inches long. That is a fact in this problem. If an angelfish is 8.5 inches longer than a clownfish, so an angelfish is 8.5 inches longer than a clownfish. So now we know that angelfish are two things. They're up to 12 inches long and they're 8.5 inches longer than a clownfish. We want to know, how long is a clownfish? Well, when you read a word problem involving algebra, the thing that you're looking for is going to be what you use a variable for. So in this case, we want to know how long a clownfish is. C is going to equal the length of a clownfish. This is called defining the variable. We're saying what the variable represents. Well, what do we know about clownfish? We know, based on our word problem, that an angelfish is 8.5 inches longer than a clownfish. So if we knew the length of a clownfish, to find the length of an angelfish, we would do what with 8.5 inches? Well, some of you are thinking we need to subtract. But remember, the angelfish is longer. So we would take the length of the clownfish and not subtract from it. We would take the length of the clownfish and add to it to get the length of the angelfish. Well, how long is the angelfish? That's right. The angelfish is 12 inches long. So if I take the smaller clownfish, C, add to it 8.5 inches, I will get the longer angelfish, which is 12 inches. You really have to take the time to think through these word problems and really think about what you're going to write when you write an equation. Now that I've done that, I can use the skills I just learned in examples 1 and 2. Here is my wall of an equal sign. I need to get the C by itself, which means I need to move 8.5 away from it by subtracting 8.5. Well, if I do it to this side, I must also do it to the other side. Being careful to line up the 8 with the 2 because 8 is a whole number, 0.5 is a decimal, which means I'm going to add a decimal and a 0 to 12 so that those things line up. Then I can borrow from 12, making it 11, and then I can make my 0 a 10. 10 minus 5 is 5. I drop my decimal straight down, and then 11 minus 8 is 3. Notice the bigger looking number was the 12, so the answer here is positive. I put my equal sign. 8.5 and negative 8.5, those are opposites. They cancel out. So I can just drop down the C. So my solution is that C equals 3.5. But then remember that this is a word problem. So let's go back and make sure that this answers the question and makes sense. How long is a clownfish? Well, an angelfish can grow to be 12 inches long. An angelfish is 8.5 inches longer than a clownfish. So the clownfish is smaller. This says 3.5 or 3.5 inches. Is 3.5 inches smaller than 12 inches? Yes. So a clownfish grows to be 3.5 inches long, while an angelfish can grow up to 12 inches long. So our answer does make sense. Go ahead and try D on your own after the video. Let's move on to the addition property of equality. The subtraction property of equality said that we can subtract something from both sides of the equation. As long as we subtract the same thing from both sides, the equation remains equal. The addition property of equality states that the two sides of an equation remain equal when you add the same number to each side. So this is exactly the same thing, except instead of subtracting the same number, you're adding the same number. So take a look at example 4, which says x minus 2 equals 1. Well, again, our equal sign, we need to pretend that that's like a wall, and we want to get x all by itself on that side of the wall. Negative 2 is the extra thing that we have over here, so we want to do the opposite of that. So the opposite of subtracting 2 is adding 2. Well, whatever I do to one side of the equal sign or my imaginary wall, I need to do to the other. So I'm going to add 2 to both sides of the equation. So negative 2 and positive 2, they cross out because they equal 0, which means I'm going to drop my x down. And then 1 and 2 are both positive, so I will just add them together, which gives me 3. So my solution is x equals 3. So adding to both sides of the equation. You can do E, F, and G after the video, but let's go on to our last word problem. So number 5 says, a pair of shoes costs $25. This is 14 less than the cost of a pair of jeans. Find the cost of the jeans. So like what we did on example 3, when I have a word problem, I want to first identify what is the thing that I'm trying to find, and that is the cost of the jeans. We're going to make that our variable. So J is the cost of jeans. So we define our variable first. Then we need to go back and look for our facts. Pair of shoes. Shoes cost $25. So shoes cost $25. Then we have, this is 14 less than the cost of the jeans. So this, what is this? Well, this is the cost of the shoes. So if we actually read this, it says $25. This is. The word is, if you look over at the word wall, underneath the word equals, you will see the word is. So we can say 25 equals 25, this equals. And then it says 14 less than the cost of the jeans. 14 less. How do I show 14 less than jeans? Well, if J is the cost of the jeans, 14 less would be subtracting 14 from the cost of the jeans. So the cost of shoes, $25, is 14 less than the cost of the jeans. So the opposite of subtracting 14 from J, because again, I want to get J all by itself on that side of the equal sign, would be to add 14 to both sides. Subtracting 14 and adding 14 are opposites. So they cancel out. So I can just bring down my J, bring down my equal sign, and then I have two positive numbers over here on the left-hand side, 25 and 14, and that equals 39. So again, going back to what is J? J is the cost of the jeans. So jeans cost $39. Now, let's go ahead and make sure that our answer makes sense. It says a pair of shoes costs $25. This is $14 less than the jeans. So the shoes cost less than the jeans. Therefore, the jeans being more expensive at $39 makes this answer make sense. So now that you know how to solve equations by adding and subtracting from both sides, why don't you go ahead and do the letter problems on your own